Hey everyone. So last week, lot of queries came to me regarding from especially from database developers who are doing development in traditional databases and languages like T-SQL, PL/SQL. That if they want to become data engineer, what is the path? And they have spent around 10 plus years in the industry in the traditional database development. Is this the right time for them to move to data engineering path? And if yes, then how can they move, right? So in this session I will be covering everything, a lot of details. But first of all, let me tell how industry works, like from where data engineering fields came in picture, right? So if we see traditional um, departments in industry, right? So the first department is software engineers. These are the people who develop your they can be divided into multiple fields like UI development, backend developer, but these are the people who are developing application for you, right? For example, if we consider the banking application, then there are people who develop the mobile banking application which you see when you open your mobile, right? So this is, let's say, ABC Bank. Then login, then password, you hit enter, then you go to the next one. You can do some transaction, make payment, transfer money, lot of things. You can log out, and lot of stuff going on. So the people who are developing this particular screens are UI developer. Who are developing this flow, the payment flow, different types of flow are kind of backend developer, right? But behind the scene, there will be database for sure, in which every transaction what these people are making will be stored, right? And there will be kind of procedures which will be written behind the scene. These are defined by the database developer, right? DB developers. So right now we have covered UI developer, backend developer, and database developer. So if we see here into the software engineering part, I think we can cover all three: UI, backend, and database developer. Now, from past 9 to 10 years, we are hearing a new term, not even not 10 years, let's say 6 to 7 years, 5 to 6 years, we are hearing a new term called data engineer and data scientist, right? To be honest, these database developer, long time back, with Oracle database, SQL developer, they are almost doing the same thing. They are acquiring the data, they are processing it, they are kind of governing the data. There are rules who can see the data, who cannot see the data. These guys are doing it. But these guys were doing this all the acquisition, processing, or governance only on traditional Oracle or RDBMS databases. Maybe that is Oracle, maybe that is SQL Server, or maybe that is MySQL, right? But these are traditional databases. But now, as we know, from 2003 2004, there is huge amount of data which is not structured, right? The data may be semi-structured like email, JSON file, or and can be unstructured like images. So that's where these people were not able to process this data using traditional technology, and that's where the new term called data engineer comes in picture. So somewhere the database developer or database uh, traditional ETL developer. So basically, when we talk about database developer, right? So what database developers are doing, they are developing procedures, they are using T-SQL, they are using SQL, and then there are ETL developer. ETL developer. What this ETL developer is doing, they are moving data. So basically, into my case, I was database developer come ETL developer. Most of the people who know ETL kind of know database development in a lot of detail. But let's think about ETL are the different people, ETL developer different. What they and what these people are doing, they are extracting the data from the source, they are transforming it, and they are loading it somewhere, right? So they are extracting it from here, they are transforming it, and they're loading it from source to destination, right? But these people, these traditional ETL developer people, are only dealing with structured data. structured data, right? This data can be in the form of CSV, or majorly in 90% of the cases, this is some source database, right? So now let's come to data engineer. So data engineers are also doing exactly the same thing. Like they're acquiring the data, they are processing the data, they are loading the data somewhere, then they clean the data, and then they load it to somewhere where some other people can use it. Who are those some other people? They can be data scientists, these people, right? Or they can be other visualization developer as well. So either these people, data scientists, or some visualization, like visualization experts, who can be using tools like Power BI or Tableau. But we do not need to worry about these people as of now. Let's focus on this part first, right? So these people are doing ETL. The people who call themselves as data engineer, they are doing ETL, to be honest, but they're not doing ETL using traditional tools. They may be using traditional tools, but they are using the tools like Spark, Scoop, Hive, Pig, Plume, like different kind of stuff. I'll cover that later, right? But they are the people who are acquiring data, processing it, governing it, and wrangling it, so that people like data scientist or visualization expert can use the data with ease, right? So software engineers are the people who are developing application, and these application will generate the data for you. The data can be of structured type, unstructured type, semi-structured type. Then there are data engineers who are acquiring the data, loading it somewhere, cleaning it, transforming it, and loading it again somewhere, so that people like data scientists and visualization expert can use it. Now this is the flow. So one thing is easy to understand, that these people, right? These people, database developer and traditional ETL developer, are doing the same thing what data engineers are doing, but they are only doing that thing with a limited set of data. That set of data is structured set, right? So now the question is, how easy for them to move to a new field called data engineering? Guys, you are already doing data engineering, but only on subset of the data. To do this data engineering on further another set of data, you need to learn new tools, and that's where we're going to be covering, right? So now, what data engineering is in reality? Data engineering is the practice of designing and building of data pipelines, and those data pipelines can collect, store, and analyze the data at scale. It's a broad field with application in just about every industry. Organizations have ability to collect massive amount of data, and they need right people and technology to ensure data is highly usable state and reaches the data scientist and analyst in proper, clean, and transformed way, so that these people, data scientists and analysts, do not need to worry about two things or three things. They should have clean data, they should have quality data, and what we said, single point of truth, right? So the data what these people provide should be ideally, let's say if we say this data is correct, then the data should be correct. Okay, so now what data engineering is? Data engineering is a skill or is a practice to build this kind of system which will provide collection, storing, and analyzing of the data at scale, right? So now, who are data engineers? So data engineers are the people who are practicing that data engineering practice, right? So data engineer is an IT worker whose primary job is to prepare data for analytical and operational use. These software engineers are typically responsible for building the data pipelines to bring together information from different data sources. They integrate, consolidate, and clean and structure it for analysis application. They aim to make it easily accessible and optimize their organization's big data ecosystem. In simple terms, data engineers are the people who are doing ETL job, who are writing ETL pipelines, so that they can provide clean, and transform data to their data scientist and data analyst, right? The amount of data an engineer, now the question is how much amount of data or what is the size of the data which different data engineers need to process. So the answer is this depends on your company or your organization, right? So data engineers are somewhere the bridge between your software engineers and data scientists or data analysts, right? Now data scientist can do, like, data scientist obviously is a big broad term. In data scientist, maybe there are people who are more towards visualization. There are people who can do model training, and when we talk about visualization, they will be developing reports and dashboards. These reports and dashboards, I think, are nothing new. They are developed before as well, but I think the name won't be data scientist. They will be visualization developer or something, right? This is new fancy terms which are into the market for last 5-6 years, right? So what data engineering will do? So data engineering is a bridge between the source system and the target system. In the source, we have the data creation and data capture. We have the sources who are producing data for you. And in the destination, we have the analyst and data scientist who are extracting the information or the value out of the data you're providing. So what exactly you are doing here as a database data engineer, you will be pulling this information into, let's say, data lake. You're just pulling each information into data lake, or in traditional environment, it's a data warehouse, right? And then you are running some jobs onto this data warehouse or data lake. You are cleaning the data, you're transforming the data, you're loading it again into a new volume, and then this data has been used by the data science team to visualize it, to have some fancy dashboards like this, right? And some graphs, some bar charts, something like this. This is the whole life cycle, And now the question is, where does the data engineering sits in the industry? So to be honest, what data engineers do, they will be talking to everyone in the industry, in your company. So they need to talk to software engineering team to understand the log. Then they need to understand the analytics or the purpose. For example, there's a data science team. They want to see the forecasting for how many people will be joining the bank in the month of November in 2021. And they said, okay, for this forecasting, they need data for last 3 years. And what the data they need? They need number of people who logged in per day, right? From which device they logged in, from which geography they logged in, and how many people get error, how many people, what is the time, response time. So these kind of stuff they can ask for, right? So this is what analytics team will do. So data engineers will talk to analytics. Then they will say, okay, these 5 types of data they need. They will talk to then software engineering team. Okay, guys, do we have this kind of data into a log? If yes, then that's fine. But if not, then they will guide software engineering team that, guys, you need to change the application logs, or you need to produce this data so that I can clean it, acquire it, clean it, and give it to the analytics, right? So this is one flow from here to here. Now, data engineers sometimes needs to understand, not sometimes, most of the time, they need to see the big picture. For example, if you're developing the pipeline, right, from source to destination, if you don't know why you're doing it, if you are just acting as a black box, you won't be able to optimize it. So, right, so as a data engineer, you need to understand the business of it, like why we are doing it. Is our only purpose is to acquire data, or to get value out of this data? This is where data engineers needs to talk to everyone, from data science team to analytics to visualization team, software engineering team, and they will be dealing with business analysts as well on multiple occasions, right? So now the question arises, what is the hierarchy of the data, or analytics hierarchy? So first what we do, we are collecting the data, right? So collecting means data acquisition. Then we clean the data. Cleaning means just remove anything which is not useful to us. For example, let's say uh, if we are dealing with customer login information and customer ID is the main field for us, and somewhere the customer ID is null, then we will say, no, I don't want this data. Or let's say we are dealing with customer bank, the date on which the customer joined the bank, joining date. And if it's null, please ignore it. So there's certain kind of rules. In collection, we don't care. We just uh, dump the data into some data lake. In cleaning, we will write our cleaning logic into some language. We'll cover it later. Then in defining and tracking, so in defining and tracking, what we say, map out the user journey from acquisition to conversation to usage to retention, and also define the metrics to track the drivers of your top line goals. So what it means that defining and tracking means we need to have the relationship between different data sets. For example, if we have multiple types of files coming, let's say customer file, address file, um, customer address, and then payment file, then we need to have some information around how this file can be joined and kind of metadata of these files, right? And obviously then we will analyze the data, and then we will use the data to optimize and predict the outcome of the data. And this is where data science team will come in picture, right? So now I think it is start making sure that in your organization, if you are traditional database PLSQL developer, you are almost doing the same thing, but using only PLSQL or maybe Informatica or maybe other ETL tool, or maybe you have written your own data migration scripts or your own ETL scripts, right? And your ETL scripts or your ETL tool is only valid for CSV files, Excel files, and traditional databases. So now, but behind the scene, you're almost doing the same thing in different way. Okay, but now with different types of data or different variety of data, there are different languages, different tools, different DBs which are coming in picture now. So when we talk about programming language, right now you guys might be using Java, you might be using Python. You can use any programming language. So you can use SQL, which I think database developer already know. You can use Python, Java, and Scala. Then there's so many big data frameworks which are kind of distributed. And again, I have covered it in a lot of detail in other lectures. But when we talk about traditional databases, we are talking about a small amount of data, which can be processed on a single machine. When we talk about big data or big data, there are different V's, right? Volume, veracity, velocity, variety. So when we talk about big data frameworks, we need to perform it in a distributed fashion. And that's where this new framework will come in picture. This new framework can be Hadoop, Spark, Hive, Storm, and Flink. And there are other frameworks as well which are in development or which some other companies are using. Then we are doing ETL here, right? So we are extracting it, transforming it, and loading it. In between, we are cleaning it, or we are doing a number of transformations. So how these jobs are interacting with each other, how these jobs are dependent on each other, we need some orchestration, right? So for orchestration, we have Airflow, which is, I think, leading in the market. Then we have NiFi, ADF, and AWS Data Pipeline as well. Right now, the new thing is Glue, AWS Glue here, right? Then we have different clouds. So right now, industry is moving towards cloud. So we do not need to worry about the infrastructure since we are talking about big data. So we don't know how much volume is coming or how much variety of data is coming. And we don't want to have our own prem cluster, right? So what people are doing, people are developing the cluster onto the cloud, and they're using software as a services. So they do not need to worry about installation of service as well. So they are kind of in the cloud. They are asking the cloud service provider, okay, give me the cluster of, let's say, Spark of 550 nodes. On these nodes, install this software. And just on the click of the button, these machines are configured, right? And in DBs, right now also, we are almost using the same database of what you guys are using in the traditional databases, Oracle, or MySQL. But since we are dealing with different data sets like structured, semi-structured, unstructured, we need to go for other databases as well. For example, MongoDB, PostgreSQL, or different kind of stuff, right? And then in the data warehousing, you might be using Teradata. This is traditional data warehouse. Then there are new data warehouses coming in the picture now. For example, Azure provides Synapse Analytics, Google provides BigQuery. There's some data warehouse provided by the Snowflake or Redshift by the Amazon, right? These are different tools. Now the question arises, I already covered it, but what are the roles that data engineers do, So they process the raw data, right? And then they build the infrastructure to consolidate and enrich the numerous data sets. They handle large scale data processing. They monitor and maintain the system. It means when they hit the play button, they need to make sure that data moved from source to destination, and number of rows in the source should be number equal to number on destination, number of columns should be number of destination, and number of things. They need to monitor whether this job is successful or not, right? And obviously after this data is dumped here, they need to prepare it for data analysis so that data scientists can use it, right? So now so what data engineers do? Build the data pipelines to pull together data from different data systems, aid data scientists in integrating, consolidating, and cleaning the data, structures and organize data to use for specific analytical applications, right? And there can be a number of roles what people can be doing. Like if I say data engineers, and if you talk to different data engineers from different companies, their role will be looking too far apart. Like different data engineers in different companies are performing different roles. It's the same, different Java developers in different companies might be writing different kinds of application, right? So some people are very general, like what they're focusing on, they're focusing on developing end-to-end data pipelines. So in companies, like let's say if your company has 1,500 employees, and if you have a data engineering team, and this data engineering team consists of 4 to 5 people, these 4 to 5 people will be general data engineers who will be doing everything. What they're doing, they will be developing data pipelines, they will be knowing data sources, they will be interacting with business, they will be interacting with data scientists, they will be building end-to-end data pipelines. Then in big organizations, there will be pipeline-centric engineers. Like their only job is to bring the data from here to here, and if this pipeline runs, they're always done, right? And obviously, when I'm talking about the sources can be of any type. They can be streaming data sources, they can be CSV, there can be other data sources. Once data is dumped, there will be other data engineers who will be cleaning this data, right? And then there are people who are database-centric engineers. Database-centric engineers are the people like who are working with traditional ETL jobs and who are transforming the ETL jobs maybe into new type of big data ecosystem, right? So database-centric project at large multi-state National Food Service would be a design analytic database. In addition to creating the database, the data engineer would be write the code to get data from where it's collected and the main application database into the analytic database. So in simple terms, what these people are doing, database-centric engineers, they will be maintaining analytical database, right? So now, what they do, again, see, I have answered this question multiple times. What they do, they acquire the data, they clean the data, they build, maintain, and test the data pipelines. They collaborate with the management. They create new data validation methods and the data analysis tool, ensure compliance with the data governance and security policies. Now, the big question, how to become one data engineer, right? So there are different people who want to become data engineers. I have already covered how PL SQL developers can become, but let me cover it in very general. And then if we have further question, you can ask me in person, or you can put comments into this video, and we can look into it. But to be honest, to become the data engineer, you need to know one programming language. For example, if I ask you to become data engineer, database developer, you will what language I need to know? You will be saying that, guys, you need to know PL SQL, PL SQL or T-SQL. These are the language for database developer, right? For data engineer, these are okay. You need to know SQL, you need to know maybe PL SQL or T-SQL, but you need to know the programming languages. And this programming language can be anything like Python, Scala, Java, R, but you need to know any programming language. And one more thing, you do not need to be super proficient. You just need to know the basic flow of the programming language. Then you need to know how automation or scripting work. So I would prefer, and I am a big fan of shell scripting, and you need to know the cron scheduling as well. Cron scheduling means how we can schedule the job onto the Unix or Linux framework, right? Then you need to master one of the distributed processing framework. I'm a big fan of Apache Spark, and that's where market is moving. So I would recommend that go ahead with Apache Spark. And for streaming, so there are two types of data, right? One is batch and one is streaming. So for batch, I would recommend Apache Spark. Here you can go for Spark. For streaming, you can go for Spark plus Kafka, right? And then you need to understand your databases. And database understanding means you need to understand both SQL and NoSQL databases. So SQL obviously is good. Data modeling you need to know. And for the unstructured data, you need to go for any NoSQL databases, whether it's MongoDB, HBase, Cassandra, different kind of stuff. Then you need to orchestrate your workflow. It means you need to, let's say one job is dependent on other job is dependent on some other job. Right now, you might be using tools like Control-M, other tools for orchestration, but industry is moving toward open source, and Apache Airflow is the leader for orchestration. Orchestration means scheduling a job, monitoring it, and having the dependency of one job on another. And then you need to know something about cloud computing as well. So how cloud is different from on-prem, and the market leaders are three: AWS, Azure, and Google Cloud. You need to learn only one cloud. And what I feel like, all three clouds are almost similar. The names of services are different, right? So you can work or learn any one cloud. Then one more thing is, and these are not very important, but if you have, then it's good. So right now, companies are moving toward Dockerization and the Kubernetes. So what these people are doing, they are developing applications into Docker environment, and they're deploying those Dockers into the production. And they're orchestrating it using Kubernetes. And there are new trends coming in market. And I think these, for example, Databricks. Databricks is the market leader in Apache Spark. So every year they are providing new features to the Apache Spark. For example, the latest feature is Delta Lake, right? What this Delta Lake is doing, you can do update or you can do CRUD operation onto the Data Lake very easily. So you need to keep yourself updated. It's not like you just learn this and you will become a data engineer. So for example, and I'm not telling you guys that you guys learned the database development or PL SQL and you are not learning anything. For example, from Oracle 9i to Oracle 12c or Oracle 11c, you have learned a lot, right? You learned the new feature. But in Oracle, we are only talking about one company. But here, if you see here, we are talking about n number of companies and number of languages. So this spectrum is very broad. So you need to be aware of that. So to become and to acquire the data engineering skills, you need to learn every day. So keep learning to become a good data engineer. Okay. This I have covered in a lot of detail. Now, the question is, if you're not a data engineer and if you want to become one, so the two important things. One is go for a certification, right? And when we talk about certification, there are a number of companies who are providing certification. For example, Cloudera is a market leader, and then Snowflake, then Google is providing, then IBM is providing, then AWS is providing data analytics software. One of my favorite certification is this one, Cloudera Certified Professional Data Engineers. Why it's one of my favorite? It is covering everything from data ingestion to data cleansing, to data transformation. It is covering everything. It is covering almost each and every tool, right? But still, if you want to go for cloud specific certification, you can go for GCP professional data engineer, or AWS, or maybe Azure certification is at 203, sorry, DP 203, right? But this is important. You need to do some certification so that your resumes look good, you know, and people, especially the recruiters, what they search for, they search for certificate certified data engineers, so that they can easily trust them, right? Now the big question: how do I need to make a portfolio so that my profile looks like a data engineer, right? And this is where I will be helping you guys. So these all things which I just which I was telling you for last 10 to 15 minutes are available in everywhere in the internet. But how to build a portfolio of the data engineering projects? And when I talk about data engineering project, at least you need to know 3 to 4 data engineering end-to-end projects, right? And this is where I will be helping you. My plan is to have published or post at least 3 to 4 data engineering projects end-to-end with the full code and everything in coming 1 to 2 months. And you can use this, you can ask doubts and try to relate these projects in with your current role, right? Now, again, I'm covering the same thing, but you need to learn any language, Scala, Python, Java. You need to learn tools in which you can collect and ingest the data, like Kafka. Here can be Spark, right? Then you need to store the data somewhere. You can store it into HDFS or into some cloud. Then you need to process the data. For processing, you may use Spark or Hive. People are not using MapReduce, but you need to learn MapReduce, you know. So you need to start your journey from MapReduce, because this is where you will get your basics clear, and then you can learn new stack like Spark or something else, right? But the main thing is you need to have 3 to 4 data engineering projects into your kitty, so that you can be more confident when you face interviews. One more thing is, which I found very, very informative, is there are different type of data sources when we talk about data engineer had to deal with. So relational databases, obviously, this is where you guys who are database developer are super handy here. So these are database RDBMS, right? There can be RDBMS, transactional one, and transactional one and analytics one. So this is data warehouse. So you have 2 types of databases in RDBMS. One is your data warehouse. Now, when we talk about these systems, JSON databases, key value databases, columnar databases, or file system, so this is all about structured data. When we talk about RDBMS, this is all about structured data. This may be semi-structured or unstructured data. So, for example, MongoDB, Redis, Apache Sbase, Cassandra, or HDFS. When we talk about cloud, we have Azure Blob Storage, AWS S3. This is all about any type of data. They may store structured, semi-structured, unstructured data, right? So I think this is all about data engineering side, right? So what data engineers do? Data engineers will be talking to different people across the organization to understand their data requirement. And then they will be talking to business, they will be talking to software engineers, they will be talking to data scientists to understand data need. And then they will be writing data pipelines to extract data from different data sources, okay? But 1 or 2 end-to-end projects are needed. And you need to have your role clear in your mind when you want to move from your traditional database development to data engineer. That's all for today, guys. Thanks a lot for the time.